So we're done essentially with types of mechanical waves. We've classified waves into whether it's transverse or longitudinal, or maybe mechanical and electromagnetic wave. We have already discussed these definitions. We have some idea on what periodic waves are. Now, let's go to a more mathematical formulation. Kasi kung napansin nyo, puro diagrams yung nakita nyo. Meron pang mga kadeting nag-aano eh. Diba? So, let's go to some mathematical description of a wave. So, how do we describe waves mathematically? Again, the point of this course is to describe the motion of objects mathematically, right? So, punta tayo doon on the mathematical description of a wave. So let's focus on one class of waves, which are harmonic waves. So harmonic waves are waves formed when the disturbance is a simple harmonic motion. Like for example, if you have a series of springs, ito yung pinaka-classic dito, ang tawag dito loaded string. So may spring ka dyan, may spring ka ulit dyan, may spring ka ulit dyan, and so on, may spring ka ulit dyan. Dito actually nagsa-start yung wave equation derivation, pero hindi natin pag-uusapan yon. Ang point dito is if since the disturbance is based on simple harmonic motion, then the motion of this loaded string here will be harmonic. The wave that will be produced by this series of spring mass systems here is harmonic. So yun yung ibig sabihin pag sinabi mong harmonic wave. Okay, so the disturbance again follows simple harmonic motions. That is the acceleration. In that case, kung meron kang wave dyan, di ganyan na siya, di ba? Parang ganyan. Assuming it's transverse, pwede naman kasing longitudinal. Do mas madali kasing i-drawing yung transverse. So in this case, the up and down motion of the disturbance, in that case, is first the acceleration in this direction, which is now we call y direction. The acceleration in the y direction is negative proportional to the displacement. Kasi di ba yun yung characteristic ng simple harmonic? A is proportional to negative x, that case. But in this case, hindi na yan x, y na yan actually. Ay na yan. The acceleration in the y direction is proportional to the negative displacement in the y direction. So proportional, so or in that case, a equals negative ky. Or k minus, sorry, this is minus ky. Okay? Yun yung ibig sabihin pag sinabi mong harmonic wave. Okay? May tanong ba rito? Are there any questions, guys? Let me erase this first. Okay, so wait. I think there's a chat here. None. Okay, so mukhang wala namang tanong. So, this is an example of a harmonic wave. And as we see here, this system here, this mass here, is moving in simple harmonic motion. It's a back and forth motion. We believe the acceleration is negative proportional to the displacement. So in that case, the wave that will be produced by this system here will be also back and forth. So in that case, it's a harmonic wave. Okay, so that's one example of a wave. Okay, so now, there are some quantities that we can measure on a sinusoidal harmonic wave. So, for example, we can measure the total distance between two higher, this top here, itong top na to, kasi gumagalaw siya eh, no? Yung dalawang, ayan, itong wavelength na to, ang measurement ng wavelength dyan ay from crest or the top version to another crest. Again, kailangan babalik. So, this is again from crest to crest. Okay, so wavelength is from crest to crest. Pwede naman kahit anong position. Basta pwedeng crest to crest, pwedeng trough to trough, and so on. So in that case, and also you have amplitude, which is the maximum displacement from equilibrium, as usual. And the period, which is the time it takes to complete one cycle. The time it takes to complete one cycle. Okay, so yon. So these are some of the definitions that we need. Yung iba dito familiar, like for example, amplitude, na-discuss na natin yan. Period, na-discuss na rin natin yan. Though yung wavelength, medyo hindi pa natin na-discuss kasi remember, for oscillations, ang position dependent lang sa time. Ngayon, meron ng spatial distance or spatial dependence, I should say. Okay, so in this case, we can calculate the speed of that sinusoidal wave. Kasi kung napansin nyo, since it's moving, then definitely it has some speed. The speed then is not, this speed is not the same as the speed of the disturbance. Hindi siya yung speed ng particle na pababa-paakyat. Siya yung speed ng pag-travel ng wave. Okay, clarification. That speed is the speed of the traveling wave, not the particle disturbed. Okay, so the speed of that sinusoidal wave is the total distance it travels in a period divided by one period. It looks like this. So V is the total distance divided by one period. Ngayon, that total distance traveled in one period is the wavelength. Di ba? Kung napansin nyo, kasi since one period is pumunta dito, papunta rito, it's one wavelength. Therefore, and the period is inverse of the frequency. One can say that the speed of a wave is just the wavelength divided by period, or the wavelength times frequency. Okay? Ito yung pamilyar sa ating V equals lambda F. It's basically the total distance divided by time. Okay? Questions? May tanong ba rito? V is lambda F. Do not forget this equation. Thank you for the response. Do not forget this equation here. V equals lambda F. Okay? Malinaw? Malinaw sa atin to? Are there any questions? Wala? Okay, mukhang wala naman. Sige, let's proceed. So, for a wave with wavelength lambda and frequency F, we can calculate other quantities. Like, kasi kung naalala nyo, di ba, sa periodic motion, ang daming pinapahanap: angular frequency, amplitude, minsan energy pinapahanap. Ganun din sa waves. You can also determine or have some description on these waves. That is, if we have a wave with wavelength lambda and frequency F, then the wave number, which we can define as the pwede mong isipin siyang frequency in the spatial domain. Pwede mo siyang isipin ganon. Mas magandang isipin na ganon. It's the frequency in the spatial domain. This is not a formal definition. This is just, pwede mo siyang isipin ganon. Doon ko siya iniisip actually. So it's the frequency of spatial dimension. It's denoted by K, which is 2 pi over lambda. Okay? Oh, well, in particular, it's angular frequency in the spatial dimension. Okay, it's again 2 pi over lambda. The units of K is inverse meter. Inverse meter, or actually it's radians per meter. Yan yung units niya. So pag nakita kayo ng units sa radians per meter, wave number yan. Okay, then second, here other, of course, you have angular frequency, or your usual temporal angular frequency, which is 2 pi f, or 2 pi over t. Ito, familiar sa atin to. Ang units niyan ay radians per second. Again, similar to oscillations, sa wave function later, kailangan nakaset sa radians ang calculator nyo. Okay, do not forget that. Pag yan nakaset sa degrees at answer kayo ng exam at lumabas yung sagot, mali yung sagot nyo. Okay? And then, after that, you have wave speed, or the total speed of the wave, which we can define to be, again, it's lambda f, or you can also check it's actually omega over k, or wave number over, angular frequency over wave number. You can think of it this way, because this is actually equal to lambda f, where lambda is 2 pi over k, pwede mong pagbalik na rin yan, and then k, omega is 2 pi f. Okay? Sige. Okay, again, for oscillations and waves, radians ang units na ginagamit. Radians talaga. Okay? Clear? Huwag kakalimutan ha. So medyo ingat pala sa exam, especially since a shuffled one. There are some items that you need to use degrees in your calculator. There are some items that you need radians in your calculator. So medyo ingat ng konti para hindi kayo malito. Okay? Questions? May tanong? Do you have any questions? So, do not forget these definitions. More or less yung iba naman dito ilalabas sa crib sheet, so, or sa list of equations. So more or less yun yung kailangan bisaduhin. Yeah. So here are some of the definitions that you need to understand for you to go to some description of waves. These are some mathematical definitions on waves. Okay, so again, I'm emphasizing this in the previous slide. Wave speed is not the same as particle speed. Ibig sabihin, yung speed ng disturbance ng wave is not necessarily the same as the speed of the propagation of the wave. They're two different things. Okay? They're different. Malinaw ba tayo rito? Is this clear? Questions? Wala? Mukhang walang tanong. Sige. Okay. Sige. So, now, let's go to, of course, as I said, these are the quantities that describe the wave. The question is, when is a wave a wave? Diba? Yung tanong doon kapag ba naglagay lang ako ng disturbance dyan, wave na agad siya. The answer is we can actually determine whether a wave is a wave by looking at its equation, or we know that it's a wave equation. A wave is a wave, or a quantity is a wave when it follows or when it satisfies the so-called wave equation. Ano ba yung wave equation na yan? Ito yung tsura niya. Let's say we have a wave with speed v. Then the shape of the wave, ang ibig sabihin ko ng shape dito, halimbawa, kung naalala niyo yung sinusoidal wave, di ba? Yung shape niya yung sine. Or yung kaninang impulse, halimbawa, di ba, meron kang string, ito yung pulse, ito yung shape na yon. So this is y as a function of both x and t. That function y as a function of x and t is called the shape of that wave. The question is, what does the shape of the wave satisfy? If the wave has some velocity v or has some speed v, then the shape of the wave should follow this equation here. Sir, ang complicated naman yung equation na yan, ba't ganyan yan? Well, sorry for that, ganyan talaga yung equation niya. Ang tawag dyan ay second order partial differential equation. It's a second order partial differential equation in both x and t. Yan. So, okay, that is the shape of the wave. Sir, ano? Yeah, exactly. Sorry for that, hindi to math 21. So, kaya kailangan natin i-discuss ng konti ano yung partial derivative, very slightly. So, in that case, the function y of x and t is known as the wave function. Or, ang tawag dyan wave function, itong y of x and t na to. We will not solve exactly this equation. Hindi nyo pa kaya i-solve yan. Actually, medyo mahihirapan din akong i-solve basta-basta yan. In fact, in other courses, this equation here is solved numerically. Sinusolve nila yung numerics yan. Numerics ginagamit nila pag solve ng wave equation. But, okay, sige, meron kang equation ng ganyan. Ano bang ibig sabihin ng mga curly-curly? Ano yung partial? Ano yung, bakit siya partial? Ano yung ibig sabihin ng partial dyan? Okay, pag-usapan natin ng konti yon. Okay, again, any solution or any form of y of x and t which satisfies this equation here is a wave. That's known as your wave equation. Okay? Eh sir, di ba wala naman dun sa Math 21? I know, kaya hindi nga natin isa-solve exactly, di ba? Pero pag-usapan muna natin ng konti, eh sir, ano bang ibig sabihin ng equation na yan? Basically, these are derivatives. Pero, remember, ang naalala nyo, di ba, ang definition ng wave, y is now a function of position and time. Hindi na lang siya single variable. Eh di ba sa Math 21, anong pinag-uusapan? Single variable calculus. You only have one function or one independent variable and one dependent variable. But in this case, we have two independent variables, position and time, and there's a one dependent variable, which is also position. Okay? Now, pag sinabi mong partial derivative, ibig sabihin lang nun, you are taking the derivative about that one particular variable. Kasi may dalawa ka eh. So, pwede kang pumili, dun ba sa x o dun ba sa t? Okay, yun lang ibig sabihin nun. So, in a nutshell, of course, there is a more formal definition, but I won't discuss it anymore. So, kapag nag-take ka ng partial derivative ng isang quantity, you are taking the derivative of one of the variables and then you treat the other variable as constant. Paano yun? Halimbawa, meron akong function dito na x squared sine of 2y plus x. Lakas maka-math 21 ito. Ay, math 23 actually ito. Pero then, if you take the partial derivative of f with respect to x, isipin mo lang na lahat ng y dyan, kasi may y dyan eh, constant. Yun. So parang isipin mo na parang ito ay 6 lang. Just as a number. And then, pwede mo nang isipin na ito, the rest ay derivatives with respect to x. So, di ba? Yes, ganun lang siya. Kala-kala na komplikado, hindi sobrang complicated yan. So, in this case, partial with respect to x, you can just use multiplication or product rule here. Product rule to kasi meron kang dalawang terms dito. Tapos, yung y dito, isipin nyo lang na constant. Wala kang iisipin dyan, kundi constant lang sila. Because x and y are independent. So, yes, ganun lang siya. And if you take the partial with respect to y, and then the x squared, lalabas lang yan kasi hindi siya dependent kay y. So, constant lang si x squared. So, ang kailangan nyo lang i-take na derivative yung sa sine kasi may y doon, no? So in that case, ang derivative ng sine of some 2y plus some constant here is 2 cosine of 2y plus x. So, nakuha. Again, for partial derivatives, it's basically taking the derivative of one function, ignoring the other. So para lang din siyang math 21 na may konti ka lang na other variables dyan. Okay? Malinaw? Clear? Yun lang naman ibig sabihin ng interpretation to. You can think of this as acceleration in the x. This is, bakit x squared to? Sorry. This should have been t squared. Sorry, typo yan. T squared yan, sorry. So, weird lang. Sorry for that. In that case, think of this as the acceleration in time. And this is basically acceleration. Again, this is not acceleration, but acceleration in x. Or the change in y, the second change in y with respect to x. So, ganun yung isipin yung wave equation. Now, it turns out na may solution yan. In general, ang solution niya ganito. Napakasimple interpret actually ng solution ng wave equation. A general solution looks like this. So, y of x and t equals y of x minus vt. Anong ibig sabihin nun? Ano na naman tong variables ito? Ang ibig sabihin niya ganito, if you have a wave with some shape given by y, pag nag-travel siya with some speed v, parehas lang yung shape. Okay, yun yung isang property ng wave. Dapat hindi nagbabago yung shape ng wave mo. Like this, for instance here. Halimbawa, you have a disturbance here in this direction. What happens is if this is traveling with some other, after some time, dapat yung shape niyan, ganyan pa rin. That's an example of a wave. Kahit pa mukhang pulse yan, kahit hindi yan mukhang sinusoidal, basta fina-follow niya tong equation na to na that shape doesn't change in time, then it is a wave. Okay? Kalimutan nyo muna si wave equation, hindi nyo kailangan masyado yan. Pero the point is, a solution of the wave equation is that the shape of that wave shouldn't change in time. Okay? Questions. So, yun lang ibig sabihin ng solution ng wave equation. Kailangan parehas yung form ng wave equation habang nagta-travel siya in time. Because that's what a wave is. Parehas dapat yung shape. Yung y of x and t niya hindi nagbabago when it's traveling through time. Okay? Is that clear? Malinaw? Malinaw to? Are there any questions? I hope there are no questions. Sige. Okay, clear. Mukhang clear naman sa ating lahat. Again, the wave equation is second order both in space and time. Okay, partial squared x, partial squared y, partial x squared is 1 over v squared, partial squared y, partial v squared. Okay, the shape of the wave, we can interpret it as follows. Ang shape lang ng wave hindi nagbabago pag nagta-travel siya. Yun ang ibig sabihin nun. Okay, yun yung solution ng isang wave equation. Okay, are there any questions?
None so far.
Thank you very much. Wala na namang tanong. Sige. So, let's go to what maraming solutions ng wave equation. In fact, since it's a second order partial differential equation, maraming sagot yan. Maraming pwedeng mag-satisfy na functions for the wave equation. In fact, the form is simply y of x and t is y of x minus vt. Ngayon, we will focus on one particular type of equation, which is the sinusoidal wave. Kasi ito yung pinaka-simple. Relatively simple siya. Kasi the sinusoidal wave has this form. Y of x and t is a cosine of kx minus omega t plus phi. In other books like Tipler, halimbawa, sine yan. We will be focusing or we'll be using a convention wherein our wave function, this is our wave function or the shape of the wave, is a cosine function. Okay, again, k here is the wave number. Omega here is the angular frequency. And phi is the phase of the wave. Okay, some books remove the phi kasi tinaas na nilang 0 ang phase. Pwede naman. And A here is the total amplitude with respect to y. Okay, so that's the generic version of our sinusoidal wave. Ito yung kailangan nyo maalala. Kailangan nyo maalala tong form ng y of x and t na yan. Okay, so you have a sinusoidal wave and ito yung itsura niya. Again, it is a traveling wave, both with respect to this distance or in the x position and also in time. Okay, so we have a sinusoidal wave, a cosine of something, kx minus omega t plus phi. Okay, so ano ibig sabihin nito? Pag tinanggal ko yung x dependence or yung spatial dependence, or tanggalin ko muna yung, mali. Ang tanggalin ko muna ay yung temporal dependence. Pag tinanggal ko yung temporal dependence niya, so in that case, what happens is all the omega t's will be just constants. And this y of x here, ano mangyayari sa kanya? Ano lang yung mangyayari? If I remove the temporal dependence or the time dependence of that wave, you only have a function of space over space. And ang itsura niyan ganito. So this is x and this is y. So parang nag-freeze yung wave mo. Hindi nagta-travel yung wave, nag-freeze yung wave mo. So ganun yung itsura niya if time is not there. Kung walang time dyan, ganyan yung itsura ng wave mo. On the other hand, if there is no spatial dependence, if position is constant, then y of x and t will only be a function of time. Magiging y of t na lang yan. And lahat ng x dependencies wala na. In fact, what happens is mag-stay sa isang position yung particle at dun lang siya gagalaw. It looks like this. Yan. Kung napansin nyo, nasa isang particular position lang siya which with in x direction, nasa isang position lang siya up and down. and it just moves there. So para ka lang merong oscillatory body na parang meron kang x equals a cosine of omega t. Okay? The combination of the vertical of the motion in time and the motion in space constitutes a wave. Yun lang ang gusto kong sabihin dito. Kasi one, if you remove the temporal dependence, the wave will freeze and you have a sinusoidal static sinusoid gen there. And when position on the other hand is constant, you have an oscillating body in simple harmonic motion, a cosine of omega t. Okay? Malinaw ba to? Is this clear? Are there any questions on this point? May tanong ba? None. Okay. So again, a sinusoidal wave is one example or one solution of the wave equation. Okay, sige. So, sir, di ba kung napansin niyo, nagtataka ba kayo bakit a cosine of kx minus omega t yan? Bakit negative? Eh sir, di ba usually positive naman yung ginagawa, blah, blah, blah. But it turns out that there's a reason why is it negative. Remember the form of the solution of the wave equation, y equals y of x minus vt, right? So this means that this wave here is traveling with respect to the positive direction. In one bit, it's in the positive x direction. It's traveling to the right. So if the wave is traveling to the right, then the form of the wave function becomes this. So ayan yung wave na papuntang right, di ba? Ito yung itsura niya. It's a kx minus omega t. Minus. Pag right, negative. On the other hand, if it's traveling to the left, pagbaliktad yung direction niya, if it's traveling to the left, then the velocity is negative and you have a cosine of kx plus omega t. So the negative sign of the angular frequency denotes the direction of the wave. Okay? Either kapag negative, it's to the right. Pag positive, it's to the left. Malinaw? Negative to the right, positive to the left. Questions? Questions? May tanong ba rito?
None so far po.
Mukhang wala naman. Sige. So, okay. So, okay.